Hello everyone, this is Greg from ChemCore. This is the explainer video from the bond line formulas worksheet that is available on my YouTube. If you haven't had a chance to try this out, check out the description below and try this on your own. There's also an answer key with the same answers in this video available in the description. And if you haven't had a chance to watch the topic and you're not really sure about how this works at all, also in the description below, make sure to check that out. In this question, they're asking us to convert condensed structures to bond line structures. And condensed structures are kind of like literal representations. Like we're literally kind of translating a bond line to a condensed. So if you're having trouble with it, maybe watching me do the first time will help explain. So CH3 is telling us that we have a carbon on this vertex. Remember that every vertex is a carbon. So if we just draw zigzag patterns, we should get the carbons on every single turn or every vertex or every end. CH3 somehow connects to carbon that has an oxygen somewhere near it, right? An oxygen. And then probably a nitrogen, right? This is once again a literal representation. So if you remember your Honk rules, carbon wants to have 4 bonds. So somehow, remember, there are no charges here. They don't give us anything here. If we had a charge, they would specify, but we don't. And so somehow, carbon has to have 4 bonds in the structure. Every carbon has to have 4 bonds. This carbon at the end, the CH3, makes sense because it has 3 hydrogens that are not shown. We don't draw hydrogens that are connected to carbon. This next carbon, though, doesn't have a hydrogen. Instead, it has an oxygen and a nitrogen. So what if we were to draw the oxygen up and then the nitrogen next to it, the next coming up? Well, then this carbon would have 3 bonds, which isn't right. And so if it makes sense, well, this oxygen wants 2 bonds anyway. And so a pattern that you'll see is that, if you have just CO or CHO and there's nothing after the oxygen, well, maybe that's a sign that it's a double bonded oxygen, right? Oxygen wants 2 bonds. And if there's nothing after it, well, then maybe the oxygen is double bonded. And it makes sense that the nitrogen should be next to it, next to the carbon, and not onto the oxygen. Because if the nitrogen was connected here, for example, well, then this carbon would again have not enough bonds. And so we'll redo that and have nitrogen connected to the carbon. There's a hydrogen connected to the nitrogen, very literal representation. And then we have CH2, right? Try to keep that zigzag orientation. CH2, and then another O. So maybe draw another O. And then a CH3. So if we try to analyze what we just did, this hydrogen is connected to this nitrogen, and it makes sense because this nitrogen ends up having 3 bonds. And then we move on to the carbon. We don't show hydrogens, but what we end up noticing is that this carbon ends up having 4 bonds, which it wants, right? Because it's connected to nitrogen, 2 hydrogens, and then an oxygen. This oxygen ends up having 2 bonds as it wants, and the end carbon, the terminal carbon, has 4 bonds again. Why? Because it has 3 hydrogens and 1 oxygen. The next problem, HO, once again, this is really a literal representation. Let's write HO, because maybe that's a clue what we need. Then we have C, just one C. There's no hydrogens attached to this carbon. However, what do these parentheses mean? These parentheses mean is kind of like, I imagine it like PEMDAS from math, if you remember. This PEMDAS is really telling us that this carbon, both of them, right, because there's 2 of them, must be attached to this carbon. And so what we can do is really draw like 2 maybe ears on this carbon. And then continue with the terminal carbon, this one, right? Because this is also connected to this carbon. And then if we analyze, this oxygen is happy because it has 2 bonds. This carbon, right, this C is happy because it has 4 bonds, right? 2 of these CH3s and another CH3. And really what they could have wrote this condensed formula like this. Well, not they. I could have written this condensed formula like this, right? Because this is really the same thing. And then notice that the way they write this, there's many ways we can draw a bond line that would fit a condensed formula. And so we kind of have to follow it very literally to make sure that we draw the correct bond line. It's a literal translation. It only means 1 bond line structure. And I included a lot of practice throughout this worksheet with these parentheses. I think it's useful. The next problem, CH3, and get used to seeing CH3 at the ends and throughout the structure. That means a terminal carbon, and terminal carbon just means it's at the end. Other carbons would be as vertices in a bond line structure, but terminal carbons are kind of at the end, and they count as carbons because they have three hydrogens connected to them and only are connected to the rest of the molecule by one bond. And so we have this terminal carbon and then this next carbon connected to another carbon. But let's analyze this really quick. This only has one hydrogen, so let's draw it just for understanding purposes. Well, how does that happen? If it's only connected to one other hydrogen carbon and it only has one other hydrogen, well then we're missing one bond. And so one way to really do this is try a double bond. So let's try a double bond. That gives this carbon 4 bonds. And then this carbon also has a hydrogen. And then it's connected to a nitrogen. And that also makes sense for this carbon because now this carbon also has 4 bonds. So let's just erase this hydrogen. Then this nitrogen is over here. Remember that this parentheses means that this is like a separate attachment to this nitrogen. Very, very literal representation. So maybe you draw this like as a stick, right? This is another terminal carbon, CH3, sticking up. And then next to it, again attached to this nitrogen, is another middle carbon, right? CH2. And then another terminal carbon. And this makes sense why I analyze CH2. Again, 4 bonds, nitrogen and carbon, and 2 hydrogens. And this terminal carbon, again, makes sense. It's only connected to one other carbon and 3 hydrogens. It's happy with its 4 bonds. The next problem, we have CH3, the 3 of them, 3 terminal carbons, in parentheses. So we think, the way they drew it, probably literal representation, it's probably connected to this carbon. So if we draw a carbon, maybe like a center, like an apex, and then 3 carbons surrounding it, 1, 2, 3, that makes sense, and it's all connected to this carbon. And if we continue it with this CH3, well, that makes sense because this middle carbon now has 4 bonds, and it's happy. And this CH2 is kind of the middle of the chain. Continues, another CH2, and then a C. And let's stop for a second. We have just carbon with no hydrogens. That means if it's connected to an oxygen here, for example, and an oxygen here, somehow we have to end up with 4 bonds. And so one way of doing this is, you wouldn't be wrong if you do a double bond this way, but convention is, and you'll maybe understand why in the next chapter, we draw the double bond going down a little bit off the chain, and it continues with oxygen in the chain. We kind of like to keep this little horizontal part a little continuous. And so we have OO, right? Again, a very literal representation. This OO is a literal representation of what's going on. And then OO, the only way, well, this oxygen for now only has 1 bond. How do we make it have 2 bonds? Well, we continue with this next CH2 and this next carbon. And notice, at this point, you should notice that, maybe write it off the side, CH3 is a clue that it's terminal, right? It's at the end. And CH2 is a clue that it's, let's write in the chain. In the chain. So it's probably a vertex. Is it spelled with an E? Yeah, it's spelled with an E. Vertex. And that's a little clue for you guys to keep going with the structure. And trust me, at first it might seem very difficult, but as you keep going through this, it gets easier, trust me. The next problem, CH3, CH2. This CH is probably the terminal, once again. CH2 probably in the middle of the chain. And then we have carbon, and then another carbon, right? Interesting. Let's maybe write carbon, and then carbon. Well, that's an interesting dilemma we have here. This carbon, right here, ends up having only 2 bonds, the way we see it, right? This carbon's happy, it has 4 bonds. But this carbon, if we were just to connect it by 1 bond to the next structure, and we'll erase this and make it look nice, well then this carbon definitely isn't happy. It only has 2 bonds. We need to have it 4. And so another clue, CC, the only way for you to do that is to make it a triple bond, like so. And if you continue this, well, think about it. Now this carbon is happy, CH2, and it has 4 bonds. This carbon is also happy, it has 4 bonds. This carbon is also happy, this is the CH2 that we're continuing right over here. And if you consider this carbon, it's again happy. And so this is maybe a new concept for you, but if we had to draw this as a bond line, the triple bond ends up linear. It's in the chain. We draw triple bonds like this. I know I probably didn't mention it in the topic video, but this is something that you should get used to. We draw triple bonds as in the chain, kind of linear, like a straight line. You should get used to this. This is convention, and most professors would actually mark you wrong if you were to write it like this, like that. That would be wrong for most professors. They would consider that incorrect. And so just be careful. Make sure your triple bonds are always linear. Next, let's just check. Let's catch up what we've done. CH3, CH2, C, C, CH2. And if it's CH2, again, it's probably a vertex. And so let's continue this chain. Let's clear that up, make it a little prettier. CH2, and then again a C. And notice that this C does not have any hydrogens. Another clue, once again, notice that this is a really big pattern of these double bonded oxygens, right? And if we continue with this nitrogen, that makes sense. This carbon has 4 bonds, no hydrogens, it's happy. And then once again, this parentheses is kind of a literal representation. We're all connected to this nitrogen. So we'll have these 2 terminal carbons sticking out of nitrogen to make it happy, right? Remember your honk rules, and if you're not familiar with our honk rules, check out the Lewis structure video in the topic video playlist and brush yourself up on that, because this is a really helpful mnemonic to get through these problems. The next structure, we have CH3 again, terminal carbon. CH2 probably a turning point, and then C. So somehow we have this C that has no carbons connected to another carbon. So I think this carbon is, this parentheses is a little representation. So maybe let's have it branch off. Notice that these parentheses are kind of PEMDAS. They're little branches, right? They're branches that come off the chain somehow. They're not really connected to anything else. So this CH3 is happy. And then somehow, just for a second, let's draw this C and this C. Somehow, if we were to do one bond, well, this carbon has no hydrogens. So it's really not happy. It only has 3 bonds. We have to give it 4 bonds somehow. So if we were to maybe draw a double bond over here connected to the next carbon, maybe that'll work. So let's see. Maybe we have this carbon right over here. Let's keep it as a Lewis structure for the second. Has a hydrogen, and then it connects to another carbon. Let's make sure that this carbon is happy. 1, 2, 3, 4. It's happy. It has 4 bonds. So let's fix that. Make it a nice bond line structure. Fix that as well. Keeps going down. This is the next CH2, right? This one. And this carbon is somehow connected to 2 terminal carbons. So let's try to work that out, right? This would end up giving it 2 terminal carbons, and then we have another hydrogen that's not drawn, but it's happy, right? It has 4 bonds. At this point, I want you to stop and realize and look at the structures that we've drawn so far. Notice that all of them follow the zigzag pattern. And it's really important that you guys get used to drawing the zigzag pattern, because this is how bond line structures work. Notice that why do we need the zigzag pattern? Well, because we can clearly see where the carbons are, right? If we kept drawing kind of like this not zigzag pattern, where do we know where these carbons are drawn? So if we draw straight lines that zigzag, we know exactly what carbons are there, what bonds are there. Everything is really clean, and it's universal, right? Anybody can read this. The next structure, we have these 2 CH3s, so probably 2 terminal carbons, something like that. Let's clean that up. Connected to a second, the carbon right over here. And it's, just for a second, let's draw this out, right? It's connected to another carbon somewhere down low. But if we connected it with just a single bond, well, that wouldn't work, right? Because now it has 3 bonds. So we have to somehow give it 4 bonds. And I think the only way that'll work is by giving it a double bond, right? So this is the next carbon right over here. That's where we stopped. And if we continue this with the chain and we checked, well, now this carbon has 1 hydrogen and 3 other bonds. 4 bonds total. It's very happy. And this CH2. And now it's connected to an oxygen. CH2 connected to an oxygen. Then connected to CH2, CH. And then we have this parentheses connected to carbon right over here. So this is probably a little branch point, again, like a terminal branch point. And then we have another CH2. We have another CH2 right over here. And then somehow, this is an interesting point, this CH2 must be connected to another carbon, so right over here. But somehow, this carbon is connected to a singular nitrogen, right over here, without any hydrogens. So the only way we can really do that is give it a triple bond. Let me make that cleaner. Make that cleaner right here, like C, and then triple bond, nitrogen. And notice that nitrogen is happy. Why? It has 3 bonds. And carbon is also happy. It has 3 bonds as well. And in this case, we really do write out the carbon because it's kind of an exception. We'll learn why in the next chapter. And don't forget what this looks like if you want to take my suggestion. The next structure, we have another terminal carbon, and then a CH2, then a CH, and then, this only has 1 hydrogen, so probably we have a little branch point. So Cl, that would make sense. And then another CH. Again, we have something connected to it, probably bromine. And then another CH2. So something connected. Two carbons here, probably a little vertex. And then we have a C. So if we're connected to an oxygen and then a nitrogen further down, Well, this has to somehow equal into 4 bonds. So once again, a little pattern. Let's give oxygen a double bond, a single bond to nitrogen. This nitrogen has a hydrogen connected to it, and then it connects to another carbon, and this has two terminal carbons connected to it. The next structure, CH3-2, this is another 2 terminal carbons connected to an inner carbon right over here, CH, that's connected to a C. And stop for a second. This is a similar example for what we had before. You know, if we connected these 2 carbons, somehow they wouldn't end up, you know, just a single bond. They wouldn't have 4 bonds. So what we really need to do is give this a triple bond. So once again, to catch up, this is our CH, this is our C, this is our other C, and then we have this little vertex right over here, CH2, CH2. So make that clear right over here. CH2. And then we connect to somehow an O, right? Probably an O in the middle, because it just the chain continues. And then we have CH. And then remember parentheses. So this whole little thing in the parentheses is like a little branch point. So CH2 and then Br. It's a little branch point off this little chain that we built before. And the CH2 is a little vertex. And then another terminal carbon. So let's erase these arrows that we drew just to clean this up a little bit. So something like this. CH3, we have a terminal carbon connected to nitrogen, and this should probably have a hydrogen. And CH2, probably a vertex, CH2, another vertex, another vertex. So 3 vertexes in total. And then CH, and we probably have a chlorine going on because we have a hydrogen missing. And then it's connected to another carbon. And notice that, again, we have O, and then nitrogen. So somehow we have to have 4 bonds. Probably a double bond to oxygen, single bond to nitrogen. And then remember that these are both little branch points off the nitrogen. And so if we were to draw this out, this would be 2 carbons connected together. And if we made it look nice, following our zigzag pattern, it would look something like this. The next question is asking us to convert the bond line structures into condensed formulas and then molecular formulas. So we're kind of working backwards. And I included this because it's maybe a good source of practice to maybe work the other way. So we can really see how things work and how the patterns really work with condensed formulas and molecular formulas. The answer key is a little bit more organized. We're just going to write this as it is, and verbally I'm going to say what is what, so you should be able to follow along. This first carbon is terminal, right? So it's probably CH3. To make sure we're drawing CH3. And then we have a carbon over here, little vertex. But notice that it already has 4 bonds with what it's connected to. So it probably doesn't have a hydrogen. And then we have an oxygen over here, right? Little oxygen. Then another nitrogen. And notice that this branch point, we can kind of put in parentheses, CH3. Right? It's a terminal branch point. And then it continues with CH2, another vertex, and another CH3. And so this is our condensed formula for this bond line structure. But how do we draw a molecular formula? How do we write a molecular formula? Well, we kind of want to write everything even more condensed. And how do we do that? Well, let's count how many carbons we have total. So 1, 2, 3, 4, 5. So we have 5 carbons. And if we try to count how many hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Draw them out. Try to see if you can count that. So we should have 11 hydrogens. And then we have an oxygen and a nitrogen. And there's many variations which we write this molecular formula, molecular structure, but realize that it's all the same. And if you looked at this, if you were just given this, is this very specific to this bond line structure? It's not, right? There's many different bond line structures that we can get just from this molecular formula. The condensed formula is a little specific to the bond line structure. And that's a really important concept that we're going to explore a little bit later in this chapter. But I really want you guys to remember that this formula, this molecular formula, is really not specific. There's many ways I can organize this molecule to give us this molecular formula. And so let's erase that box over there. The next structure, we have 2 terminal carbons. So maybe a C that's connected over here. So C. And notice that it probably has a CH. because it has 3 carbons that it's connected to, but it needs 1 more hydrogen. And so in parentheses, we'll write CH3. There's 2 of them, so 2 on the outside. And then it's connected to another carbon, another vertex, that has a hydrogen, so CH. And then it also has a little branch point, CH3. Let's move this over. I'm running out of space. Let's continue. This little branch point, CH3, and then we have CH2, vertex over here, and then O, just another oxygen, and then a terminal carbon, so CH3. And this is our condensed formula. And if you were to count your carbons and count your hydrogens, you should get C6, H14, and then O. And that should work. That's your molecular formula. The next structure, we have a terminal carbon, so CH3, and then another carbon, but realize that we only have 1 hydrogen connected to this because of the double bond. We have 3 bonds already, and 1 bond not drawn. That means it's probably a hydrogen. The next structure, the same story. We have 3 bonds that are shown, and 1 not, so another CH. Next carbon, again, we have 3 bonds, and 1 not shown, so CH. And then this little branch point, it's unattached. So we have this nitrogen, and we kind of have to do a parentheses in parentheses because we're showing that this nitrogen is directly a branch point off this carbon, but what's connected to the nitrogen? And we kind of have to show that it has 2 terminal carbons attached directly to the nitrogen. And let's erase this arrow. The next structure is just C, and we have no hydrogens on this carbon because we already have 4 bonds, and then oxygen, and then CH3. Makes sense. And if you counted up your carbons, your hydrogens, your nitrogens, and your oxygen, you should get C8, H15, NO. Excellent. The next structure, we have 3 terminal carbons, so connected to an internal carbon right over here. And this carbon has 4 bonds drawn, so it probably does not have any other hydrogens. So just C with CH3, terminal carbons. There's 3 of them. And then it's connected to another vertex, CH2, another CH2, and then over here a carbon. And it's connected to 2 oxygens, notice. So we can write OO, condensed formula. So O and then O. And then the last oxygen is connected to another terminal hydrogen, the terminal carbon. And that works. And if you counted your molecular formula, you should get something like C8, H16, and then O2. But you can also write this, sometimes you'll see this molecular formula as COOCH3. And although this is not fully simplified in a way, this would be an acceptable molecular formula. And you should get used to seeing COO, that it looks something like this. And we'll actually get into detail about what this means a little later on. The next structure, we have a terminal carbon, so CH3, connected to the next problem, we have a terminal carbon, so connected to an internal carbon, so right over here. We'll draw this carbon. Notice that it has 4 bonds already drawn, so it doesn't have any... The next problem, we start with a CH3, so terminal carbon. Move on to another carbon, and notice that we already have 4 bonds drawn to this carbon, so it probably doesn't have any hydrogens. And then we have a branch point, a chlorine, little branch point. And then it's connected to another carbon that has 3 bonds drawn, so it has a hydrogen that isn't drawn. And then it's connected to another carbon that has 4 bonds, so no hydrogens, and 2 terminal branch points, so CH3, 2. And we have a carbon right over here with an oxygen branching off, so CO, and then N, and H connected to the nitrogen, and then CH2, CH3. And let me resize this a little bit because this looks absolutely horrible. This should do. Just notice that this structure, let's maybe bubble it with a pencil. That it goes for this. And then the molecular structure, if you counted up your carbons, hydrogens and chlorines, oxygen, nitrogens, you should get C9, H15, O, ClN. And there's many different ways we can write this N. You can write ONCl. Sometimes it's written differently. Sometimes it's written Cl in the middle somewhere. But notice that it's no matter what, it doesn't tell you much about the structure. And so we really won't be focusing much on molecular structures unless it's a simpler structure. maybe one carbon or two carbons, then we use them. The next problem, we have a condensed formula. We start with nitrogen, and then it's connected to a carbon at this triple bond. And this triple bond, notice that there should not be any hydrogens because we already have 4 bonds in this carbon. And then next is a little vertex, so CH2, looks like a CH2, and then CH2, and then oxygen. And then the next is another carbon. Notice that we have 3 bonds to this carbon, so there should be a hydrogen connected to it. And then this branch point should be C. Notice that this is a C connected to this C, and this C has 3 other branch points, so branch points of a branch point. And then we have another CH2. This one, well, actually not a CH2. The next carbon, notice that it has 3 bonds already drawn, so it probably only has 1 hydrogen connecting off of it. And the end of the carbon, of the chain, has another carbon, but already has 2 bonds, so it's probably just CH2, because it needs 2 more. That's a CH2 at the end. And if you counted up all your carbons, and hydrogens and oxygens and nitrogens, you should get C10, H17ON. The next problem, kind of repetitive. Let's just go a little quicker. So we'll have CH3 at the end, and then the next is CH2, 2 bonds drawn, which means 2 hydrogens, and then the next carbon, 3 bonds drawn, which means 1 hydrogen. The next carbon, 3 bonds drawn, so 1 hydrogen, and CH2 connected to nitrogen, little branch point CH2, CH3. Right, these 2 carbons. This is the branch point, and then again CH2. We'll maybe write it a little smaller. CH2, CH3. We end up running out of space in these boxes. On the answer key, it looks a lot better. And then the molecular formula, if you counted up all your carbons, hydrogens, and nitrogens, you should get C10, H21, and nitrogen. And notice that we end up packing up a lot of these hydrogens in most of these structures. The next structure we have at the end, 2 bonds drawn, which means 2 hydrogens, and then CH, and then C, and these 2 terminal carbons, so CH3, there's 2 of them, and then another vertex, CH2, and then C, and then OO, so oxygen, oxygen, and then CH2, and then another carbon, and we have 3 bonds drawn, which means we just have 1 hydrogen, and in parentheses we should have a branch point, CH3. We can really just draw 2 of them, or we could just draw 1 and then another CH3, but this is another way of drawing this condensed formula. And if you counted up all your carbons, hydrogens, and oxygens, you should get C10, H20, and O2, or you can, other ways you can see OOH and remove one of the hydrogens from here. The next problem, the condensed formula, let's start with this little, let's count this, and this should be our branch point. We have CH3, CH2. Let's erase this to make it clearer for us. And this carbon has 3 bonds drawn, so 1 hydrogen. And the branch point is CH2, CH3. And then the next carbon, C, has 3 bonds drawn, so 1 hydrogen. And then an OH connected to it. We really don't draw parentheses for OH. Sometimes we do, but get used to not seeing them. And then a C, 4 bonds drawn, so no hydrogens. And 3 branch points connected to it, so CH3, 3. And if you counted up all your carbons, hydrogens, and oxygens, you should get C10, H22O. The next structure, the condensed formula, I might have to draw this like sideways or something, or it might be hard to follow. This end carbon has C and should have CH, because it has one hydrogen, 3 bonds drawn, which means 1 hydrogen. And then C, this carbon right over here has 4 bonds drawn and no hydrogens. And then we have a bunch of vertices, so CH2, CH2, CH2. So that's 1, 2, 3, 4, 5, 4 vertices. So another CH2. And then we're left with this carbon, so carbon. And we have 3 bonds drawn, which was 1 more hydrogen. Then bromine, CH2, CH2, and then O, CH2, CH2, CH3. And then notice that it really gets repetitive over and over and over again. And if we were to count up all our carbons and all our hydrogens and bromines and oxygens, we should get C12, H20, BRO. And there's many different ways you could write this molecular formula, and it's really not important to this course much. The condensed formula for this one, let's start with this carbon all the way on the left. It's a terminal carbon, so CH3. And then we have a carbon over here, and it has 3 bonds shown, which means it has 1 hydrogen, and a little offshoot, a little branch, CH3. Next carbon. And it's connected to an oxygen, 4 bonds and no hydrogens attached. And then another carbon, CH. And then we can count this as 2 branch points at the end. Or we could just write CH3, erase this 2 and just write CH3 at the end. And the molecular formula should look like something CH7, H14. Oh. The condensed formula for this one, we have a terminal carbon here all the way on the left, CH3, and then CH, 3 bonds drawn, so 1 hydrogen. And then off this carbon, we have a branch point, CH3, and then a vertex, CH2. The next carbon is here. We have 4 bonds drawn, so no hydrogens. And then Cl. We don't really have to draw that in parentheses because there's just one letter, but sometimes you can. And then the next carbon has 3 bonds drawn, so 1 hydrogen. And then another carbon, CH3, terminal. And if we counted up all our carbons and hydrogens and chlorines, we should get C7, H13, Cl. This concludes our worksheet of bond line structures. If you're feeling a little iffy about this, watch over the topic video. Make sure you're all good with the information. Maybe try the worksheet on your own again, look at the answer key, and maybe rewatch this video. And I hope this helps, and I'll see you guys in the next one.